you find a machine learning use case? Here's what I propose. Imagine that there is no machine learning. It's all a hoax. There's no AI, there's just a bunch of people on an island somewhere, sitting in cubicles behind computer screens, and you send them some information, like a photo of a cat, and they are going to con you and write back cat, and we're all going to pretend that that's the AI. Okay, imagine that. The only way you can communicate with these people is to send them tasks by example. No instructions. You're not allowed to write instructions to them, but you can send them examples. If I allowed you to use this resource for almost free, and there were a lot of them, and they were very fast, you could really scale them up, what would you use these humans for? What drudgery would you cut out of your life? And as you're thinking about that, you're coming upon the right kind of applications for machine learning. But wait, you don't know how drunk these people are. So you can't just trust them with your important tasks. You need to check that they can actually do those tasks. And for that to work out, you need to be able to say what it means to do your task correctly. And if they make mistakes, which mistakes are worse than which other mistakes? And how would you like to score that performance? Because you're going to want to check whether this island can actually do the job for you. And if it can't, you don't want to hand over control of some important process to this thing. Now, you do see these creative applications like, hey, drunk island, write me a poem. And for those, you don't really know what it means to write a poem well. If you did, you'd just sit there writing poems, right? You kind of hope for something good to come out of there, but you're not sure what you're expecting. Well, for those things, you shouldn't really hand over the task entirely to the system. Instead, what you should expect is that it is just a way to inspire your human creativity. It's just going to mush up some information for you and propose something that looks like a poem. That's just some way of combining a whole lot of data. And you're going to look at this and you're going to actually use your own judgment as the human creative, and you're going to ask, does this inspire me? Can we work with this? And if it doesn't, you're going to kick that island, tell it, hey, go do this a different way. Over and over again, until something looks like it's worth pursuing. And then you're going to do that trick that all these other folks do, which is you're going to put that out there on the internet and pretend like that was the only version ever. Look at the poem machine learning wrote for me. Machine learning writes poems, says the newspaper heading. It's actually you that's writing the poem. Machine learning is just jumbling stuff up for you in some haphazard way, like monkeys on typewriters, just a little better because it's finding patterns rather than doing it purely at random. But it's a way to filter human creativity. That's how you should think of those applications, where we're not quite sure what we're looking for. There we have it heavily interfacing with the human, and the human is at both ends of the process. And what about this other kind of application where you have, hey, drunk island, generate for me the face of a celebrity who doesn't exist. That application is a real application. That works. The technique there is called generative adversarial neural networks, or GANs, and it's all the rage these days. Here's how to think about those. There are two drunk islands, not one. Drunk island number one is taught to figure out whether the celebrity is a real celebrity or it's some fake generated image. So it's a thing labeler that's doing a bit of detecting, truth detecting, which one is legit, which one isn't. And the second drunk island is supposed to trick the first one, generate images that get past the other one's defenses. And both of them learn together and both get better at their game as they battle it out in cyberspace. And by the time they're done, the tricker is good enough at it to trick you. And its output looks kind of legitimate. Still the same kind of components. And still for both of them you need to be able to say, what does it mean for the first one to succeed? What does it mean to correctly identify the face? What is the other one trying to do? And that, if you cannot say that, you will not be able to use machine learning to solve your task.